Hello, I'm Ricky Lee, and this is the Capital Compass. Today, we're taking a look at Kraig Biocraft Laboratories, a company operating at the intersection of biotechnology, advanced materials, and molecular biology. Kraig is developing genetically engineered silkworms capable of producing spider silk, a material long considered one of nature's most remarkable fibers, but one that has historically been impossible to manufacture at scale. The company believes that is now changing, with commercial scale production and sales moving into focus. Joining me now to walk us through the business, the science, the IP, and what comes next is Kim Thompson, CEO of Kraig Biocraft Laboratories. Kim, it's great to have you with us.
Thank you, Ricky. It's a pleasure.
So, Kim, let's start with the big picture here. For viewers who may not have seen the Craig Labs work featured on the cover of National Geographic, can you give us an overview of the company and what the business you built around engineered spider silk?
Yes, thank you, Ricky. So Craig was founded for the purpose of creating a platform for producing recombinant spider silk at scale to serve commercial markets. Many people considered that to be an impossible goal at the time. There wasn't a technology to do that. Now we're the world leader in this technology in genetically engineered spider silk fiber. We have the only scalable, cost-effective platform for producing recombinant spider silk filament. We're moving from laboratory breakthroughs to commercial reality right now with a massive scale up. And we're targeting the markets for high performance material.
And a core part of those breakthroughs is the molecular biology behind it all, right? Specifically, using genetically engineered silkworms to produce spider silk. Can you walk us through how that works and how Craig's approach is so unique?
So our technology, as you've stated, is built upon the domesticated silkworm. What we do is we genetically modify the silkworm so that the silkworm is producing spider silk proteins in its silk glands, which then it combines with its native silk proteins to create a new fiber never seen on Earth before, recombinant spider silk. And the beauty of this system is we are not only creating the spider silk proteins, but we are simultaneously creating them and spinning them into fiber, all within the silkworm. That's really the beauty of this system. The silkworm knows how to produce silk proteins cost effectively, and it knows how to take those proteins and combine them into a continuous silk fiber. That is really the breakthrough of our technology over all other systems. And we've proven that it works.
And it seems like a lot of work to go into creating something like silk, right? But spider silk is different somehow. It's been talked about for years as a kind of wonder material. But what makes this type of silk more superior to traditional silk, for example? And why does that matter commercially?
Well, of course, silk is known as a beautiful, luxurious, soft, and pliant material. Spider silk, on the other hand, is known for its incredible tensile strength. Spider silk is by weight stronger than steel. It's tough. It's also simultaneously elastic and malleable, and it retains the properties of a normal mundane silk as in terms of being supple and beautiful. It's really a wonder material produced by nature. And we've created the only scalable platform for producing this material at scale. So we do feel we have a tiger by the tail.
And you say it's the only platform that does this. So I'm assuming, you must have built some significant intellectual property to protect you in something like this. How important is that IP portfolio in protecting the business? And in your view, how much real competition is there in the space today anyway?
So let's first start with the competition. So there is competition. After we published our proof of concept in the publication of the National Academy of Sciences and verified in peer-reviewed articles that this system worked, two large competitors sprung up with substantial financing, much larger than Kraig Labs. They had rival technologies trying to produce spider silk in vats of E. coli bacteria or yeast. That technology has proven to be ineffective for producing a continuous filament and ineffective on a cost-benefit basis. So we stand at this point as the only viable competitor in spider silk producing a true recombinant spider silk filament. In terms of intellectual property, we've wrapped ourselves in all the intellectual property that we can, and we continue to do so, filing additional patent applications and provisional applications on a continuous basis. But even more than that, we now have 15 years of built-in trade secrets into the technology, which would be very hard to replicate. Just as an example, the selective breeding of our silkworms. And I'm not talking about the molecular biology, genetic engineering, just the mundane breeding of the silkworms. Very difficult field to compete in. And we're the only people that we're aware of that are currently in the field producing recombinant spider silk.
And so looking ahead then, the story now seems to be shifting away from research to production. Where are you today in terms of near-term manufacturing and sales? And what needs to happen next to reach that commercial scale that everyone's been trying to reach?
So up until now, we've been producing largely laboratory quantities of material, perfecting our system. And now we are in the midst of a large-scale ramp-up in the field to produce spider silk at industrial quantities. Our near-term target is 10 metric tons of spider silk per year. And we're ramping up very rapidly. We should be hitting those marks in 60 to 90 days. We recently deployed 700,000 BAM1 alpha hybrids into the field. Those are now producing cocoon. Reports from the field are very positive in terms of production efficiency. So we're right on track to reach that commercial scale this year in 2026. Very exciting time for us at Kraig Labs, who've been working on this for a long time, and for our shareholders.
Well, Kim, thank you so much for enlightening us today about spider silk.
Thank you, Ricky. I love talking about spider silk and I love talking about silkworms. So happy to revisit this with you anytime.
And we'll be very glad to have you back again. Once again, that is Kim Thompson, CEO of Kraig Biocraft Laboratories. For more information, you can visit craiglabs.com. That's Kraig with a K. I'm Ricky Lee, and this has been the Capital Compass. Thanks for watching, and I'll see you again next time.